Welcome to the DIY Honda Garage channel. DTC P04DF indicates a potential issue in the evaporative emission control (EVAP) system of a Honda CRV 2017 to 2022 model. Specifically, this code denotes that an unusually high purge flow has been detected, which can lead to faulty emissions and affect vehicle performance. The EVAP system is crucial for capturing fuel vapors from the fuel tank and routing them to the engine for combustion. This helps minimize pollution and ensures compliance with environmental regulations. The EVAP canister purge valve plays a key role in this process by regulating the flow of fuel vapors into the engine. As part of the troubleshooting procedure, it's essential to understand the tools required, such as a vacuum pump and gauges that are designated for measuring vacuum levels. Therefore, addressing this code promptly is significant for both engine efficiency and regulatory compliance. DTC P04DF pertains to the EVAP system, which consists of multiple components working in unison to reduce the release of fuel vapors into the atmosphere. The primary component affected here is the EVAP canister purge valve, located in the engine compartment. This valve controls the flow of fuel vapors captured in the canister to the engine, ensuring that they are utilized in the combustion process rather than being released into the air. The canister itself is typically situated near the fuel tank, where it collects vapors that escape during refueling and operation. The evaporation lines connect the canister to other parts of the engine, making them crucial for maintaining proper vehicle emissions. Misfunctioning can occur due to debris or wear that affects the valve's ability to open and close properly, ultimately leading to the high purge flow error. Addressing the root cause requires careful inspection and testing of these components. The potential causes of DTC P04DF are specifically linked to the functionality of the EVAP system components. Firstly, debris in the purge valve can obstruct its normal operation, causing it to remain open intermittently and leading to excessive vapor flow. This can occur from carbon buildup or contamination from fuel. Secondly, if the purge valve is stuck open, it will not regulate vapor pressure accurately, which constitutes a serious issue for the system's integrity. This malfunction can often trigger additional fault codes if not addressed. Lastly, problems with the non-return valve can also lead to incorrect pressure in the system. If this valve is faulty, it may not prevent the backflow of vapors, creating a feedback loop that exacerbates the high purge flow issue. Identifying the precise cause is imperative to effectively resolve the DTC and restore normal function. When DTC P04DF is present, several symptoms can manifest that may significantly impact the vehicle's operation. An immediate indicator is the illumination of the check engine light, CEL, on the dashboard, which is programmed to alert the driver of system malfunctions. Additionally, the vehicle may experience poor fuel efficiency, as the improper regulation of fuel vapors can disrupt the optimal air-fuel mixture in the engine. This inefficiency can lead to increased fuel consumption and potentially higher emissions. In some cases, failing to address this DTC may result in problems during an emission test, as the high purge flow could cause the vehicle to exceed allowable pollution limits. Hence, drivers are advised to be vigilant about any performance changes and address this error code promptly. Failure to take action can lead to more extensive repair bills and environmental repercussions. The first step in troubleshooting DTC P04DF involves verifying the issue. Begin by turning the vehicle to the on mode, which prepares the onboard diagnostic system to evaluate any existing fault codes. Following this, Utilize the Honda Diagnostic System, HDS, to clear the current DTC. This step is essential to eliminate any potential transient faults that may have been logged. After clearing the DTC, select the EVAP test (ELCM) option from the inspection menu on the HDS, then proceed to conduct the EVAP leak check module test. This test will determine if any leaks or system faults can be detected that may have contributed to the high purge flow. If the test yields a pass result, it may point toward an intermittent issue, suggesting that the system is functioning correctly under current conditions. However, if not, the next stages of troubleshooting must be escalated to locate and remedy the core problem. In the second troubleshooting step, focus shifts to inspecting the EVAP canister purge valve directly. Begin by removing the purge valve from its mounting location, while keeping its connector and vacuum hose attached for initial checks. Once unmounted, disconnect the vacuum hose connecting to the purge valve in the engine compartment. This is a critical step, as it allows for the introduction of diagnostic tools necessary for the evaluation of the valve's functionality. Attach a T-fitting, along with a vacuum gauge set to measure pressures accurately, and use a vacuum pump to apply about 2 kilopascal, 0.6 inches per inch, or 15 millimeters per inch of vacuum to the purge valve. At this stage, you're assessing the valve's ability to hold vacuum. If it retains this pressure, the next steps in the diagnostic process can continue. Conversely, if it fails to hold vacuum, immediate replacement of the EVAP canister purge valve is warranted to resolve the issue. The third troubleshooting step is focused on the non-return valve, a component integral to the proper function of the EVAP system. Begin by thoroughly inspecting the non-return valve for any signs of blockage, wear, or failure. This valve plays a critical role by preventing the backflow of vapors, ensuring that the system maintains the appropriate pressure levels necessary for optimal operation. If, upon inspection, the non-return valve appears to function correctly, the next recommendation is to proceed with the replacement of the EVAP leak check module, since it may be contributing to the problem. However, if the valve is found to be defective or clogged, it should be replaced immediately to rectify the issue, as this can create a domino effect impacting other components in the EVAP system. Correctly diagnosing the state of the non-return valve can help ensure that further issues with high purge flow are avoided. After any repairs have been completed related to DTC P04DF, it is vital to conduct thorough verification to ensure that the issue has indeed been resolved. Begin this process by reconnecting the HDS to the vehicle and rechecking for any DTCs that may still be present. This step will confirm if the repairs address the problem or if further investigation is needed. Following this, conduct another EVAP leak test to ascertain that all components are functioning as intended and that no new faults have arisen. It's crucial that all connections related to the EVAP system, including hoses and valves, are securely fastened to prevent any potential leaks. If the results are satisfactory and no further DTCs appear, you can confidently conclude that the repairs have restored the system to proper working order. To prevent the recurrences of issues similar to DTC P04DF, it's essential to embrace proactive maintenance measures for the EVAP system. One of the simplest practices is to regularly inspect the entire EVAP system, including hoses, valves, and the canister itself, looking for signs of wear or debris. This will help catch minor issues before they escalate into major faults. Another valuable strategy is to clean the components periodically, especially the purge valve, to eliminate any buildup that may cause operational problems later. Additionally, using high-quality fuel can reduce the likelihood of contaminants entering the EVAP system, which could lead to malfunctioning components. keeping a maintenance log and performing routine checks can go a long way in ensuring the long-term functionality of the system, thereby aiding in lower emissions and sustained fuel efficiency. In summary, DTC P04DF signifies an important issue within the EVAP system involving high purge flow. Understanding the roles of various components, like the EVAP canister and purge valve, is crucial to effectively diagnose and resolve the issue. The step-by-step troubleshooting process provides a structured approach to identify and rectify potential faults in the system. After any repairs are performed, verifying fixes through rechecking DTCs and conducting tests ensures that drivers can trust their vehicle's performance. Finally, integrating preventive maintenance practices such as regular inspections and choosing top-quality fuel will aid in avoiding similar issues in the future, allowing for a smoother driving experience and adherence to emission standards. Please like and subscribe to the channel. See you next time.